I will be discussing today about our experience running experiments in the software industry. This talk reports on results of a research project funded by the Finland Distinguished Professors Program. In that project, the University of Oulu is working with 6 companies. The aim of the project is to push forward the experimental paradigm in software development. For more than 30 years, software researchers have been conducting experiments in the laboratory, but experiments in industry are really scarce. So conducting experiments in software companies is in the forefront of software engineering research. Field experiments are such an essential part on the experimental paradigm as laboratory experiments. So we need to gain insight on the challenges of running experiments in industry, in software industry, as well as increase our understanding on the difference between running experiments in the lab and in the field, in our discipline, the software companies. And the project also aims to increase software industry awareness on experiments and what experiments can do for software companies. So let me start by the beginning. What experiments are of use? Why do we want to use experiments? Experiments are at the core of the scientific method. So science and engineering disciplines are using experiments to reveal cause-effect relationships. By running experiments, we discover key characteristics, key variables of software development, as well as the connections among such variables. Those variables and their connections is what is known in science as the mechanisms ruling certain phenomenon. Those mechanisms are hidden, and they produce, those variables and their interconnections produce a behavior that is the behavior we observe in software projects. So experiments provide an answer to the question why things happen as they do in software development. All engineering disciplines have taken this similar step of getting away from speculations, lucky guesses, beliefs, towards scientific knowledge. Using scientific knowledge, engineering achieve predictable results. That is, in fact, what we aim. By experimenting with software development, we will be able to gain knowledge, very high quality knowledge, scientific knowledge about software development, and the use of that knowledge to build software should make software development a much more predictable process. So experiments will produce for software development scientifically valid findings. Such findings identify weakness, strengths, as well as applicability conditions of software technologies. So why is this relevant for industry? Basically, an experiment is a comparison, so we can compare anything about development, tools, techniques, methods, even developers' abilities. And what experiments produce is a quantitative, objective information of such comparison. So companies could use such knowledge to write up in fact-based management. meaning base your development decisions about software projects on an objective ground, in such a way that software development become better controlled, being a more predictable activity. Okay, so let's go more in depth on what exactly I am meaning by experiment. Let me start by what experiment is not. This is important because the term experiment and experimentation is very often used in the common language with a quite relaxed meaning, while in science, inside the scientific method, in engineering disciplines, experiments have a very strict meaning. In fact, for an empirical study to be an experiment, it must satisfy certain very restricted restrictions. So, experiment is not a one-shot experience, as in the typical sentence, my son is experimenting with drugs. No way. Exactly, an experiment in engineering means the other way around. It doesn't mean a one-shot experience, it means a systematical approach. So, the problem with the one-shot experience in general is that they are not general at all. If I once went ballooning and I didn't enjoy, I didn't like, that doesn't mean I will not like next time. Or even it means less that another person will neither enjoy. So, one-shot experience results are not general, while what we want in experiments aim to produce general results. So results applicable not only to one developer, but to several engineers, several companies, in the best case, worldwide general results. In fact, there is a type of empirical study called case studies, you might have heard about it, that they have been more often run conducted in software companies. They resemble more this idea. So they study one case, one project. They are a very nice type of investigation to gain understanding on development, but the output produced is applicable only to that project and not to other projects. And that's not what experiments aim. Neither experiments is a synonym of experience, the long-term experience gained by a manager along his professional life. Experience is, as we all know, very valid type of knowledge, but the problem is that typically is interiorized in the mind of that person with experience through rules of thumbs, etc. So that person is able to somehow predict certain behaviors of, in that case, software projects, but that knowledge is not transferable to other people and is quite subjective based on her experience of her life. So experiments aim to be just the other way around, to produce pieces of knowledge useful that can be used by any person, so they are not implicit but clearly explicit, and they are not subjective but objective and quantitative. And it might be that in some of your companies you are collecting data from projects. That's a very good practice, but that's neither an experiment. That's what we call an observational empirical study or a study based on historical data. They are good to have certain level of predictions, but that type of study is not able to reveal cause-effect relationships. That is what we are looking for in experiments. Why? Because in the real projects, there are thousands of variables interacting and some effects are being produced, but we are not able to assign, to identify which of those thousands of variables are the cause for certain effects we are observing. In fact, An experiment then is a very controlled situation. That's why we sometimes call experiments controlled experiments, to make the difference with quasi-experiments or some type of experiments called non-real experiments. The typically controlled experiments, as the term shows, means that we are in a very controlled situations. Therefore, it is not a real project. So experiments are like a type of lateral exercise. They are not in the mainstream. You don't run experiments inside a real software project. You run in a side experiments to learn, and that knowledge then can be applied in the real projects. The other thing we need is a lot of people. We need a lot of participants. So one person developing something and another person developing that same something is neither an experiment. Why? An experiment has two main type of variables. Those we are observing, measuring. Typically they are interesting features in development, so productivity of developers, code quality, efficiency, etc. Imagine we have an experiment about productivity. We want to learn, to discover if, imagine A and B are two programming languages. If programming language B that is new and someone is trying to sell to your company, you want to know if your developers use this new language, you will get really that better quality that the seller is saying it will. So we have here productivity, we have here the new programming language B, and there the programming language A. So I was saying you need several participants, because if you only have one person using programming language A and another developer using programming language B, and you find this is more productive than that one, you will not be able to know if the reason is the programming language or the person. So that's why you need several people to cancel somehow the influence of developers in the output we are measuring. Since we are trying to reveal this type of cause-effect relationship, if I am trying to understand if the programming language can be a cause for the productivity, you don't want that knowledge to be applicable only to some people. You want to understand to which type of developers, etc. So you have several different people. Typically you divide, that's a basic design, you divide the set of participants in two. Some of them are applying a programming language A and some others programming language B. Okay, these people are all doing the same. So this is not the typical development team where different members of the team are building different pieces of the software. That's not the way an experiment works. Each of these people, they are doing exactly the same. You need this multiplicity, in fact, to avoid the influence of that people. So I have here 3 developers using programming language B and 3 developers using programming language A. And here the control comes. Everything needs to remain the same. So it's the same task, the same problem. Experimentalism has certain strategies to control all that and avoid the influence of other variables in productivity. So notice that productivity must in fact have been influenced by many factors, not only the programming language but many others. Good, but the experiment focused about the relationship between programming language and productivity. So you want to somehow cancel those influences. In some cases, it means it remains constant. For instance, the piece of software they are building is always the same. And some others, as the characteristics of the developers, you can cancel the influence by certain strategies. So, controlled and manipulation, that is how we call this. We are manipulating this variable, telling some of the developers, you use programming language A, you use programming language B. We manipulate the variable under study, we somehow keep everything constant, and we measure the output that we are wondering if the variable manipulated is getting an effect. So then let's go more specific. How exactly do we run an experiment? Then we need these N developers. The more the better. 30 is a typical magic number. But the interesting issue here for companies is that in research, when we are running experiment, researchers, we aim to find worldwide valid knowledge. So meaning knowledge cause-effect relationships that are valid, that are general enough to be true for any developer. In fact, for instance, in psychology experiments, this is not 30. Typically, they ask for something like 100 or 150 people in an experiment to be general enough the results. Why? Because in psychology, they aim to get knowledge that is valid for all the inhabitants in the world, and that's a huge population. For software engineering, we aim to get general enough knowledge for developers in the world, which is smaller compared with all the inhabitants. But the good news here for the companies is you are interested in getting knowledge for your company and your developers. If that's applicable to another company, good, but it's not something critical for you. That means that you are looking for knowledge valid to your population, that is the number of all your engineers. So depending on the company size, it might be that if it's a very small company, you need much less. The experiment, in fact, is a sample, less participants in the sample. Even in the extreme, if you are a teeny company with 5 engineers, you can run the experiment with them all 5, and then what you find is for sure true for your population, because you run, in fact, the experiment in the population, not in a sample. So you need a certain amount of people. That people needs to be under the same conditions. So an experiment is neither run with each developer in their working place. Why? Because it could be that some of them are talking on the phone or reading email or any other disturbance, and then the circumstances, the conditions for all of them are not the same. And we do want, remember, that the conditions are the same, so the root, the cause of the effect we are observing is just the variable we are manipulating. So typically we confine developers, the participants in an experiment, in a room, and during the time that the experiment lasts, imagine 1 hour, they are all there working, so we can guarantee that all developers have been working for the same amount of time, 1 hour. So the result is not dependent on the time they have been working. And of course that people are using the same infrastructure, everything the same except the variable we are studying. And that people are, as we said, making the same task. Then typically an experimental task lasts like 2 hours, 1, 3. So, of course, we have realized that that can be very demanding for a company. If we have 10 people, 2 hours per people, we have 20 working hours for the experiment. Or even if we have other type of design, for instance, not that one that you split, but another type where everybody do A and then everybody do B, which is a design that cancels better the characteristics of the developer, since you use all the participants in the experiment to do the both tasks. In that case, you will have 10 and 10, 20 per 2 hours, 40 working hours. So we have in the project, we have realized that definitely that might be too much. So we have come with this solution of we exchange training for developers, meaning the companies provide developers and we researchers provide free training. So the experiment is sold to the company as a training course. The only difference is, and the participants of the experiments are the participants to the course. The only difference is that that course has a major exercise element. We need that participants are experiencing making the task we need. So it has many exercises. Let me, for instance, show you. This is the TDD experiment we have run in the project. So, as the company seat is a course on TDD. We have been running the experiment on test-driven development. Remember that that is an agile, extreme practice with 3 characteristics. Development is divided, split in teeny cycles, so it pushes to the extreme the iterativeness of the development. It reverses the code test order, so rather than code test as usual, it asks for test code, so you first write a test case and then write the code to pass that test case. And the third element is you do not design a priori, but you refactor afterwards. So this is basically the TDD practice. So in the course experiment, we were in the first day reminding some testing concepts because we need to compare TDD with something. So the something will be the test last typical traditional approach. We could have started, in fact, the best case for the experiment would be we just arrive there and ask people to work for 2 hours, the way they do it. Since this was our first experiment, that approach was a little bit tricky for a course. Even if the participants were aware that that's an experiment, starting a course by 2 hours of doing it the way you know how to do it is a little bit strange. So what we did is some reminder on testing concepts and then ask them to do it. Then 1 day of TDD course, a lot of practices, as you see, because we do need that the participants really learn how to do it, and then we ask them to do certain tasks in TDD, and what we do is compare the output of those 2 situations, the first one, test last, and TDD. Okay, so let me show you what results you get from an experiment. So you put your hands on about what you get from there. Okay, this is an example. This is the F-Secure TDD experiments we have run. We run the experiments in 3 sites of TDD, so give the training course 3 times. And here, so in an experiment, you get the individual results. What this is, every couple of bars, is the result in quality of one of the participants. We were measuring quality. We collect the code that participants were producing. We run a set of test cases in every code, and we come with a quality value. 100% means all the test cases pass, 0% none of the test cases pass. So here is what every individual got from the blue, I think, is test last, and the green TDD. We agreed with the companies on not providing the individual information because, in fact, it's not needed for the experiment. The experiment works with this type of aggregated data. So this is test last quality, this is TDD. This is what we call an outlier, one person that got this value of quality with TDD. This is the minimum value, the other is the maximum value, the line in the middle of the box is the median, low part of the box, 3rd quartile, and top part, the first quartile and the 3rd quartile. So basically, the line is the median. As you can see, they obtain better median with TDD than with test last. But experiments don't rely on just having a look to that and say, yeah, it seems like they get better results. They apply very formal data analysis techniques which answer you about if that difference is significant or not. So Basically, we got an improvement on 17% for the TDD. That's why you were seeing the line for the TDD higher than the other one. But this difference is significant. And then we run statistical hypothesis tests that are able to answer that. By significant, we mean if the reason of that improvement is really the development paradigm, so TDD. The hypothesis tests answer you if that difference is really due to the variable you are manipulating. And in this case, well, that we call effect size to that, the size of the effect observed. And that's what we call hypothesis testing. So notice that even if TDD got a 17% of better quality, the tests tell us that's not significant. It's like, I am not sure that that reason is the development paradigm. There could be other reasons. And here we have the productivity, developer's productivity. In that case, and there you see the difference, and in this case we get a 24% of improvements for TDD, and it is significant. So what the test is telling us is, in this situation, in this experiment, the reason for the developers to get 24% of improvement in productivity, it is TDD. It is the development is due to the two different approaches in development. Okay, then, in an experiment, you can also exploit more the data you collect. We collect a lot of data. The results I have shown you are the typical, let's say, experiments results, but you can do a lot of other things with the data. So we call that post hoc analysis, meaning the analysis you will see now are not an answer to the experiment question. The experiment question was, does TDD produce higher quality? And the answer, as we saw, is yes, it produces, but we are not sure the reason is TDD. These things are just correlational or regression, other type of analysis. So what we did is we had a plugin in Eclipse that was monitoring what the developers were doing. So are they doing test last, test first, regression, coding, etc. We got all that data and wonder which of the three elements of TDD, the nanocycles that TDD requires, the test first, or the refactoring, are those possible causes of the quality. And what we got, interesting enough, is that the test first doesn't seem to be, although very often we call TDD as a synonym of test first. As you see, it is not. I mean, TDD requires not only test first, but also nano development and refactoring. And what the data are telling us is that it seems that the main reason for the improvement produced by TDD is due to the nano development, which is interesting because typically the developers feel uncomfortable with the test first approach, at least in the beginning. So this is giving some advice of saying, okay, you could incorporate in your company the nano development, which is something quite intuitive. Is just pushing to the extreme the iterative development to 5 minutes, 10 minutes cycles. And rather than developers can continue doing the test last. But we need to confirm this with an experiment. Again, if you see this type of post-hoc analysis, it has to do with what I mentioned in the beginning when you are collecting data from your company. If it's not an experiment, it's just an observational study, as this part of the results I am showing, to be sure that the nano development is the cause for the improvement we have observed in productivity or quality, we need to run another experiment, designed with that purpose. And that's in fact what we have done. We are running, again, the TDD experiment, but now we go for this, let's see what happens. We are running at Ericsson this experiment in a couple of weeks. We will start with the 2 hours of saying do it your way. So we really have a most interesting result for the company that is comparing TDD with the way you do it. Notice that the other information I show, it was TDD versus test last, but we were first refreshing on some unit testing concepts, etc. So it's not exactly the way you do it. So we will ask them to start the way you do it. We extract from TDD the slicing heuristics, and we train developers on that nano development style, but ask them to do it test last, and then the pure TDD. So this experiment will provide the answer if really the nano development is the reason for TDD improvement, or the main reason for TDD improvement. So, notice that these results come only from F-Secure results, which means that they are valid inside F-Secure, but we don't know if F-Secure has certain circumstances, type of developers, whatever, that can make their results different to other companies or sites or places. So we have replicated the experiment. That was one of the aims of the project. In fact, we have run already the experiment in 6-7 other sites, both universities and companies. I am going to show you the results for the other replications of exactly the same experiment than the one we ran in F-Secure. We ran that experiment also at Electrobit. We changed because it was the way the developers work, so not Java anymore, but C++. No JUnit but Google test, so the infrastructure here is a little bit different, but the design of the experiment, the training, the tasks, the rest of the things stay the same. So here you have the results we already saw in quality for F-Secure, here Electrobit, and here you have some students of one Spanish university, Politécnica de Valencia. So notice that the pattern is quite stable. In the 3 cases, we got better results for TDD than for test last. Even in the student's case, the result was significant. That's what I mean by this, rather than in this case that we got improvement, but still the hypothesis test tell us we are not sure if the reason is TDD. In the case of the students, it is. So, notice also some other interesting things, like, well, in the case of Electrobit, for instance, we didn't have a lot of participants, and then we had what we call power problems. The experiment is not able to provide powerful results, and is saying, I would need more people to give you a more valid, reliable answer. So here you have also an interesting notice how students were doing TDD compared with the professionals. That's the type of study I was saying in the beginning of the talk. We are interested in understanding the difference between running experiments in the lab and in the field. We researchers are running experiments in the laboratory, but until now we don't have much more information on the results we find in the university, in the academia, how much valid they are for professionals. So in this case, it seems that the result doesn't change sign. I mean, they are quite stable, but it looks that students perform better than professionals. We have some hypotheses on that. Like, for instance, they are used to follow strictly the guideline of a professor. This was an exam and the grade depend on their performance and some other reasons. But basically, in quality and in productivity, in the case of productivity, the 3 replications got significant results. So we can conclude that TDD leads to improvement in quality and productivity, although in the case of quality is not producing significant differences for professionals for the time being. The results are quite stable independently of the technology, and you can see, of course, the small local differences I was also commenting in the beginning of the talk. The results are not identically because it depends on a lot of characteristics of the companies. That's the part I was saying that, okay, from a company point of view, these results are valid enough. If you get enough, a big sample, enough participants in relationship with your population, so all your developers, you are okay with this and you just don't need to worry about what happened. So the local differences might be interesting for you in the sense, these are the results for F-Secure and Electrobit. If it's true in two, and we are running the experiment also in Ericsson, we are increasing the evidence of the results. But of course, from your own company point of view, if you run the experiment and get the results are valid for your case. And in fact, that's what we are doing. We are running, our doors are open to run the experiment in any company, even if they are not part of the research project. What you get is the 3 days free training on TDD. You have seen, we have like different versions of the TDD experiment. We will give you back the local results, so your results, and you would be able to start to use those objective, quantitative results to manage development, for instance, encouraging your developers to use TDD or to use the nano development, etc. And yeah, 35. That's it. Thank you very much.